Hey guys, this is Sarai Bieta. The year is 2014. My model project I'm going to be presenting is called Excitation, Contraction, Coupling. These are just a few terms that I've put out there for you. It all begins with an action potential. As you can see, there is an arrow there that I put, and that's the way that the action potential starts by. It goes to the axon terminal, where calcium-gated channels release calcium. By this action, the vesicle, which is this, if you can remember, releases the acetylcholine into the synaptic cleft, which is the space between. Alright, now, once the acetylcholine is released, they go towards the acetylcholine receptors. By this action, it allows for sodium to rush into the cell membrane. After sodium rushes in, potassium is allowed back inside as well. As the rest, the excess of acetylcholine binds into this enzyme called acetylcholine esterase, and this just breaks down the ACH. Meanwhile, the action potential continues on the sarcolemma, going down into the T tubule, stimulating calcium to be released from the sarcoplasmic reticulum. Now, this calcium doesn't just go anywhere. Now, these are just tiny muscle fibers right here that are just placed together. And to go more in depth, this is the thick filament. It's also called myosin. And the myosin has heads, which is called myosin heads. Not too complicated, but they are composed of ADP and phosphate. The thin filament, which is this, is composed of troponin, actin, and tropomyosin. The first stage is just like in any action potential. It's the resting stage. Nothing really is occurring, but here we have ADP and phosphate, and this is a little phosphate right there. And they all have this. I'll just draw it in a few, but you get the image. Okay. So we were speaking about calcium going down into the thick and thin filament. Now, here is our calcium, and once it reaches the actin, it binds to the tropomyosin, which is right here, and allows for shift, the movement to occur. The myosin heads begin to bind to the actin. This is called cross-bridge formation. And as you know, the myosin heads reach the actin, but then they begin to move it. It's called a power stroke. This means that it's going to start moving it in this direction. Now all this is part of the contraction cycle. Don't forget that our myosin heads have the ADP and phosphate attached to it right at the edge. But at this stage, once they start the power stroke, the ADP and phosphate deattach. Once the calcium goes and is reabsorbed back into the sarcoplasmic reticulum, then everything goes back to its normal stage. ADP and phosphate return back to the myosin head. The contraction cycle begins again once calcium reaches the thickened filament. Thank you, and this is just a citation.